Hello and welcome to our video notes on section 4.5, graphs of sine and cosine functions. And so we're going to start this with the sine curve, and basically if you read what it says here, the black portion is one period of the function and one complete cycle through it. And so if we're asking you for the domain of this function continues on forever in both directions. So our domain of this function is going to be negative infinity to infinity. Our range of the function will always be negative 1 to 1 unless we change the amplitude of the function, and we'll talk about that in a little bit. And the period of this function, the standard function, is 2 pi unless, again, unless we change the period of the function, which we can do, and we'll talk about that in the future. But this is the basic for the sine curve, the basic sine curve. And so make sure you get these down and make sure you get this drawing down so we can talk about it. We're going to talk about the cosine function next, and in the cosine function, well, here's the graph of it, and this black graph right here is one period through it, and so you can notice that the period is 2 pi. The range of this function remains the same. If you look, the range is the y values, and that is from negative 1 to 1. And our domain, again, this function is continuous and it will go on forever, and so that goes from negative infinity to infinity. And so this is just a matter of getting our graphs of these functions, and this is why one of the reasons we use radians is that it turns it into more of a linear function than a circular function that we get when we deal with degrees. So we're going to move on and we're going to talk about graphing these functions ourselves. And so here are the key points for our function, and this is a whole bunch more than we really need, but what we need for our function to graph these for sine and cosine is that our key points, the 5 key points, are always going to be, one is going to be the start, will be the starting point. So one key point is the start of the period, one will be the end of the period, one will be the exact middle of the period, this is the middle in this case, and then the other two will be will try to be points that will give us the max and the min in this one. So this point would give us the max, and this one will give us the minimum. And so for the sine function, so these guys, even though these are related to the unit circle, and we could plot these points, we'll have to kind of estimate for these, but they won't give us a great graph of this. So in the next graph, we're going to sketch these, and so let me put this into a split screen so you can see what we're talking about. And so it says, using the data from the table in the previous function, we want to graph our 5 key points, which will be our intercepts and our max and min points. And so in this case, we have our 0, and you can see for sine, if this is sine that we're dealing with, 0 is 0, so we'd get the point right there. And then if we have our endpoint, which was at 2 pi, we're at 0, so we have a point right there. And you can see our middle point at pi was somewhere right in the middle between 0 and 2 pi would be there. We're also at 0. So then the question is, which way are we going? If this is positive 1 and down here is negative 1, then using my table at pi over 2, which is halfway between 0 and pi, I have a point that says my y value, when I put pi over 2 in for sine, I get 1. So I'd end up with a point up here. And likewise at 3 pi over 2, which is the middle between pi and 2 pi, so there is 3 pi over 2, 3 pi over 2. I end up at negative 1, so I'd get a point down there. So I could go ahead and sketch my sine graph, which hopefully you know the way it looks is going to look something like that. So our goal when we're graphing these, our 5 key points are always going to be the start, the end, and the intercepts, and the max and min. And if the period changes in this, and we'll talk about that in just a minute, when the period changes, then we'll use our start and our end of our period, and then we'll try to pick the points in between. And I'll try to mention this when we get to talking about period change. So then we want to graph, this is one period of the sine function, and you saw that at the very beginning, so make sure you have this down. So then if we move on here, we're going to talk about the cosine function, and again, when we graph our cosine function, we want to have our starting points. So you'll notice that the starting point of cosine is going to be 0 and 1, so I'd put a point there. There's my start. My end, since we know that the period of cosine, we talked about this earlier, is 2 pi, so that would be my ending point. And at 2 pi, oops, I graphed that wrong, sorry, for cosine, For cosine, well, I have 1 and negative 1 down here. 1 and negative 1. Helps if I actually look at my starting point when x is 0, I get cosine as 1, so I get a point up here. My end point at 2 pi, my cosine also is at 1, so I get a point up there. Then my middle point will be pi, so there's the middle. And the middle point is at pi, which is right in the middle. And so this is just kind of a sketch I have when we're at pi, cosine is at negative 1, so I'm down here. And then my 2 points that are going to be in between are going to be pi over 2 and 3 pi over 2. And these may be max, they may be mins, they may just be the intercepts. And so when I use pi over 2, which is right here, and these are always the points that I'm going to use if I'm using a standard period of 2 pi. And I'm going to use these 5 points of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so then I would get at pi over 2, I'm at 0. And at 3 pi over 2, which these guys end up being my intercepts, I'm at 0. So if I was going to sketch the graph of this, I'd start at the top, and the graph falls like this. And so before, when I gave you these points, for sine, these guys were my intercepts. The beginning, the middle, and the end were my intercepts. Well, in cosine, they are the max and mins, and my intercepts are the middle points for cosine. So let's move on, and then we'll come back and talk about this in just a second. So then we can talk about amplitude of a graph, and the amplitude of the graph is basically how tall the graph is. So if I have a function that says y equals 3 sine of x, well, that basically means if my range of normal sine, if my function, we'll just quickly sketch a sine function, if my normal function is y of sine of x, and I know my range is from 1 to negative 1, so my sine function, and here's 2 pi out here, and here's pi. So my normal sine function would look something like this from 1 to negative 1. Well, when I deal with 3 with the amplitude, since it's bigger than 1, that means that I'm going from 3 to negative 3. So the graph doesn't change period-wise, it just changes height-wise. And so the graph will look pretty much the same, except for it'll be taller because I'm using a number bigger than 1, which makes the graph a lot taller than it was before. So this graph right here is the black one. And so that's just what we're talking about when we're talking about an amplitude change. So that's the number in front of sine and cosine. And so when that happens, when that number changes positive, then it's going to get taller. If it turns into a negative, it's going to get shorter or smaller. And it might even, if it's actually between 0 and 1, I think is what this should say. Between 0 and 1, the graph is going to get shorter. If it's less than 1, if it's less than 0, then it flips the graph over. Just think of these guys as normal transformations that we're dealing with, and that's really all this is. This is our stretch and our compression of our graph that we've used before. So then we finally get to talk about the period of the function, and that's the b value in these. And basically, when we're talking about sine, we mentioned that the period of sine was 2 pi. And so if I was to quickly, and cosine's the same deal. The only reason I'm using sine over cosine is that I can sketch a sine function a lot quicker than I can sketch a cosine function. And so just because of the way it starts. But so if I'm going to graph a sine function, a normal sine function, it looks something like that. There is a period of 2 pi. But if I change, that would be, so we'll say that's y of sine of x. And then if I was to say, oh, well, I'm going to change the period of this and say sine of 2x, there's two ways to look at this. One is, since there's a 2 here, that's basically saying that I'm going through this cycle that you're looking at right here twice before I get to 2 pi. So that means that instead I'll have at pi over 2 and at 3 pi over 2, I will go through the cycle. That's going to be this value is going to be, it's going to look something like this. So it goes through the cycle twice before it gets to 2 pi. That's what this period is telling me. Or the other way to look at it, when they're talking about the period up here, if you take 2 pi and divide it by 2, then the period, just to go through the cycle once, is just pi. And so going back to sketching our graph, if we're sketching our graph of this and our period changes to say pi, then my 5 points aren't going to remain at, my 5 points aren't going to be 0, 2 pi, pi, pi over 2, and 3 pi over 2. That would be our standard one if we don't have a period change. But if our period changes to something like pi with a period change, then our 5 points might be something like 0 and pi, our start and our end. The middle would be somewhere halfway between them at pi over 2. And then we want 2 values on either side of those. And so we'd have something like pi over 4 and 3 pi over 4. To keep it, so those would be our 5 points that we would get if we were going to sketch a graph of this. So when the period changes, we end up changing the values we're going to use to get our max and mins and our intercepts and things like that on our sketch. So this concludes our video notes on sketching. We will talk more about this in class. If you have any questions, please come to class prepared to ask them.